In a previous video, we talked about what happens when we add and subtract like terms. And remember, when we're adding and subtracting like terms, we can only do it if they're like terms. We can't do it when the terms aren't the same. So, for example, in this particular question, if this was an adding or subtracting, I wouldn't be able to do anything further with this expression because this m squared and this m are not like terms. But we can multiply and divide numbers and variables together even when they're not like terms. So let's see how that happens. When we multiply 2r times 6, and I'm denoting this dot here as timesing so that there's no confusion that the x is a variable or times. What we're doing is we're saying that this is multiplying. This is 2r times 6. All we're going to do is we're going to multiply the coefficients. So this is going to be 12. 2 times 6 is 12. And I leave the variable the same in this case. There's only one r, so it's going to be 12r. Pretty simple for that one. When we go to this one, when we're actually multiplying variables together, sometimes I find it actually easier to write out the product of what's actually happening for each variable. So if I just want to rewrite this, m squared is actually the same thing as m times m. So what we're doing is we're going 4 times m, and we're times it by 5m. So if we're multiplying that by 5 times m, again, each one of these dots representing multiplying, or if you want to write it with the actual multiplying, if you're used to seeing it like that, that means 4 times m times 5 times m. And we get this big long thing that really we can shorten down quite a bit. What we do is we multiply the coefficients. So if I look at the coefficients, 4 times 5 should be 20. And I've got m times m, or m squared times m. And we end up with m cubed. So the rule when we're multiplying variables together is that we actually add the exponents. Notice this here should actually be a 1. Though we don't write it, often when there's a 1, we know that it's to the power of 1, otherwise it wouldn't exist. So it's 2 plus 1 to the power of 3. If you get confused by that, you can always write it out in product form, m times the m, and I should get m cubed. So looking across over to here, we're just going to try and get from this point to this point in one jump. So 7 times 2 should be 14. Remember, when I'm multiplying variables, I should add the exponents. A squared times a cubed, one of the most common mistakes that students will make in all of algebra is that they're going to end up multiplying these exponents. And that's just because they're used to seeing multiplying a squared times a cubed, and they've already got multiplying in their head. But remember, when I multiply variables, I add the exponents. So this is a to the 5th. B times b squared, don't forget, this means the same as b to the 1 right here. So b to the 1 times b squared is going to be b cubed. That's how that one will work out. What happens when students get to ones like these is they start to tense up and it looks very, very scary because it's got all of these numbers, it's got brackets, it's got all kinds of variables to different exponent values. But really, essentially, it's the same as what we're doing here. All I want to do is I multiply all of the coefficients first. So in this case, I got 2 times negative 1 is going to be negative 2 times 2 is going to be negative 4. The key to doing questions like this is just doing them slowly and making sure that you're minimizing your opportunities for making mistakes. A squared times the a is going to be a cubed times a cubed. Remember, it's not a to the 9th. It's going to be adding the exponents a to the power of 6. B cubed times b is going to be b to the 4th. There's no b term here, so it's just b to the 4th. C times c is going to be c squared times c to the 5th is going to be c to the 7th. That looks much neater than the thing above it. And so that's how I simplify that down when I'm multiplying all the coefficients and all the variables through. In the next video, we're going to take a look at dividing variables.